So far, we've seen how to declare classes and objects, and we've seen how to make classes a case class. That's very handy. But probably one of the most powerful things that we get from an object-oriented style of programming is, as you know, polymorphism. Polymorphism comes from a Greek term meaning many forms. So we can say that a base class, if it has multiple derived classes, those will be many forms of the base class. So we're going to use that here in our cookbook to provide a bit of a richer data model for our ingredients. We'd like to actually model how much of each ingredient we need, so that perhaps we could go shopping for those ingredients later if we don't have enough. Now, there's many different units of measure for ingredients, and I don't want to get into that level of sophistication. I'm just going to use mass. So let's declare an abstract base class called mass. Now, this should be familiar to anybody coming from a Java background and from a C++ background, and not too different. You would expect that an abstract class in C++ is one that has some pure virtual functions. So let's say that our mass class is going to have an amount, and we'll say that this should be a double. And now what I want is a few different units of measure for mass. So we can say class grams extends mass. Now if we just declare grams like this, we run into a problem pretty quickly, and you'll probably recognize it again if you're coming from Java or C++, and that is, well, the mass class has a constructor. And so when we construct grams, we need to chain to the superclass constructor. The way that we do that in Scala is using a pretty consistent syntax. We specify the constructor parameters for grams, and we pass them here to the superclass constructor. Now we can do the same thing with, let's say, milligrams, and let's say kilograms. Well, this isn't a very interesting abstract base class right now because it doesn't have any abstract methods in it. So let's define one. We're going to declare that any unit of measure for mass should be able to normalize itself to grams. So the way that we'll do that is just say def to grams. It doesn't need to take any arguments because it's going to convert this to grams, right? And we'll say that it produces an instance of grams. That's all that we need to do. And just leaving off any implementation, that's perfectly sufficient. So if I save the file now, the compiler will kick in and tell us that grams, milligrams, and kilograms all need to implement this method. So let's go ahead and do that. If we want to convert grams to grams, we can say def to grams of type grams is equal to this. We don't need to actually do any conversion. If we want to convert milligrams to grams, we have to construct a new object. And likewise with kilograms here. Now, if we wanted to be explicit about the fact that the two grams methods in grams, milligrams, and kilograms are implementing the abstract method from the base class, we can say that explicitly using the override keyword here. That's not strictly necessary because the method is abstract, but if you wanted to override a concrete method, Scala requires you to specify an override. So let's do that. Let's override the toString method. We want to say override def toString, returns a string, and for grams we'll say amount plus g. We can do the same thing for milligrams, and the same thing for kilograms. Of course, there's a bit of copy and paste going on here, but we're just going to ignore that. Now again, keep in mind that because toString is actually concrete in the parent class, java.lang.object, we have to declare it as override. So let's change our data model now to use these. We'll say that instead of just being a list of strings for our ingredients, we'll say that our ingredients is a map from the name of the ingredient to some quantity, which is going to be a mass. So let's go ahead and fill in some values here. We'll just make some numbers up. we'll say that we need 10 grams of peanut butter. We'll also say that we need, let's say, half a kilo of jelly. This is going to be a very moist sandwich. And to soak up some of that jelly, let's say new grams, 250. We'll say a quarter of a kilo of bread. And for our bacon pancakes recipe, well, let's say that when we want to make bacon pancakes, we're going to be really hungry. So let's say new kilograms 1. We're going to have a full kilo of bacon. And really, I think that pancakes in this recipe are more of an afterthought. I think the bacon is most important. So let's say new milligrams 10, just 10 milligrams of pancake. And I need to make this a map. And let's save this. Okay, so let's go over to the console and see how this looks. All right, there we go. So we have our peanut butter and jelly recipe has peanut butter, 10 grams, jelly, half a kilo, and bread, a quarter of a kilo. Now, it turns out it's not super common to do things this way, just because we like case classes so much. And what happens if I try to make these a case class, let's just use this one as an example, is the compiler is going to tell us that the amount field in this case class is overriding the amount field in the parent class. Now, if we wanted to, we could make that explicit and say override val amount. Save that, and that should be okay. But it's actually more common style to just make abstract defs in the base class rather than having fields there. So let's do that instead. Let's take our amount as a double and just make it an abstract def. Okay. So now when we say extends mass, we can just leave this part off. Now you might be wondering, by the way, since with case classes the compiler generates a two-string implementation for us, but we implemented our own here, well, what happens? Because we've implemented our own, the compiler just won't bother to generate one. It chooses ours instead. Okay, so this is good. Now that they're case classes, we can do pattern matching on them. But one thing that we pointed out about pattern matching before was that we really like to know whether we've covered all possible cases. Let's say in this example that grams, milligrams, and kilograms are the only kinds of mass that we care about. So if we want to be explicit and say that these three classes are the only possible implementations of mass, so that our pattern matching can be exhaustive, we can actually be explicit about that. We can say that mass is a sealed abstract class. When we say that mass is sealed, what that means is that no other classes, besides the ones that are defined in this file, are allowed to extend mass. So mass would be essentially final from the perspective of anybody outside. Let's just try writing a simple function that prints out masses. And uses pattern matching. And let's, on purpose, let's forget a case to see what the compiler tells us. So the compiler actually warns us here. It says that it would fail for the cases of kilograms and milligrams, because the only case that we have specified here is just grams. What we've done here is implemented a very common pattern in Scala called algebraic data types. An algebraic data type consists of a sealed abstract class and then several case classes that implement it. And this is a very useful technique. Now, the last thing that I want to do here is be able to compare instances of masses. And I should be able to compare milligrams to kilograms or grams to kilograms or whatever, because I know how to normalize all of these things to grams. So let's say that mass extends comparable. This is an interface that comes from Java. Now when we do that and we save, the compiler is going to tell us that grams, milligrams, and kilograms all need to implement this. But I want to do this just once, and I can. I should be able to provide a concrete def here. Def compare to. We'll say that is another instance of mass. Compare to returns an int. We'll just return this dot to grams dot amount minus that dot to grams dot amount. Now this is a double, so we should convert it to an int. And now that we have this, we can do what I said in the beginning, which is, well, if we want to make a recipe, we need to check our kitchen and see if we have all the ingredients. So let's just implement a method on the recipe class. And let's call it shopping list. This will be the ingredients that we need to go out and get. So we have the ingredients for the recipe, and what we need is the ingredients that we have in our kitchen. So let's say kitchen is going to also be a map from string to mass. And this should just return a list of ingredients. So let's say a list of string equals, and the way that we're going to implement this is using a for comprehension. Let's stub that out. So what we're iterating over in the for comprehension is our ingredients that we need. So let's get the name of the ingredient, that's the key in the map, and we'll get the amount of mass that we need. I'll just call that need. And these will come from our ingredients, but ingredients is a map right now, so we need to convert it to a list, because a list is what we're producing. Well, the next thing that we need to find out is how much of the ingredient do we actually have in the kitchen. So let's find that out. Let's say have is equal to kitchen dot. Now I'm going to use a method on the map class that you can find in the Scala doc. It's called get or else. The reason I'm using this is because the kitchen might not actually have any of the ingredient at all. So the map lookup would fail. This is a way of providing a default value in that case. So we can say get or else name, and the default value will be 0 grams. All right, so we have how much we need, we have how much we have, and we want to compare them, because we only want to put those things in the shopping list that we don't have enough of. In other words, we want to filter using one of these if guards that I talked about before. If the amount that we have is less than the amount that we need. So if the amount that we have is less than the amount that we need, we will put the name of the ingredient in the list. One last thing that I had forgotten to clean up before, we don't have to say new grams here. We can just say grams because these are case classes now. Okay, so let's go and try this out. Let's say that I want to make a peanut butter and jelly sandwich. So we'll say cookbook.pbj.shopping list. Now what do we have in the kitchen? Well, let's say that we have nothing in the kitchen. Let's just say we have an empty map. This should tell us that we need to go shopping for peanut butter, jelly, and bread. Let's say instead that we actually have some peanut butter in the kitchen. And I don't remember how much we need. So let's say that we have 1 kilogram. Okay, apparently 1 kilogram was enough peanut butter, so we only need jelly and bread. So this last part of the exercise wasn't object-oriented programming per se, but it was enabled by an object-oriented style. We created an algebraic data type consisting of an abstract base class that was sealed and 3 classes that implement it. One last point that I want to mention here before we wrap up is that even though we've declared amount and 2 grams as def in the base class, well, amount is actually a val in the implementation classes. Right? Remember that case classes, the constructor arguments all turn into vals. Likewise, let's say we wanted our 2 grams implementation, 4 grams, to just be a val. That works fine as well. It's always legal to override a def that doesn't take any arguments. with a val in a child class. That's just fine. There are a few combinations of this. We could also say that amount is actually just an abstract val, and that's okay because amount is a val in all the child classes. But if we said 2 grams is a val, that wouldn't work. You can't override a val with a def. The rules about this get a little bit tricky, so the easiest thing to remember is just make abstract defs, and you can override them with anything that you want to. That's the most flexible way.